Okay, I'm going to try this video one more time. I just got interrupted by a tornado drill, but we all survived that. So please get out your factoring notes, and we are going to add in some notes for difference of two squares and perfect square trinomials that we did yesterday. So if you go up to difference of two squares, remember that a difference of two squares looks like this: a squared minus b squared. And we learned yesterday that that can be factored into two factors, a plus b times the quantity of a minus b. So if you can recognize something as a difference of two squares, you can save yourself some time by jumping right to that factored form. So please write this one down. X to the fourth minus 25y to the sixth. So as you can see, if we look at the square roots of each of these terms, it is a perfect square, or a difference of two squares, because the square root of x to the fourth is x squared. The square root of 25y to the sixth is 5y to the third. So this is going to factor into these two terms. Okay? Alright, now if you slide further down, we've already filled out the general trinomials, but let's do some work with perfect square trinomials. Remember that the form of a perfect square trinomial is that the first and the last terms both have to be perfect squares, and the middle term is twice the product of the square roots of these two things, so it's 2ab. And we learned yesterday that that factors into the binomial a plus b quantity squared. Okay, so for your example, let's do this one. Oops. X squared minus 14x plus 49. So you want to identify, is it a perfect square trinomial by looking at the first and last terms. X squared is a perfect square. 49 is a perfect square. And then, is the middle term twice the product of these two things? Yes, it is. And because of this subtraction sign right here, this needs to be factored into this. So that's what we worked on yesterday. And we kind of went through recognizing those patterns. And if you remember from yesterday, I emphasized that when you're factoring something, you want to go through a progression of steps. And one of the first step you always want to do is looking for a greatest common factor. And from there, you want to look for hopefully a pattern. So if you'll please open your books to page 566. At the bottom of page 566, you will see a nice chart that kind of lays out the progression. You first want to check for a GCF. Then you want to check for a pattern that fits either a difference of two squares or a perfect square trinomial. If that doesn't work, if it is a trinomial, you want to use your x method. And you can use the x method if it's x squared or if it's ax squared. And I would say step 4 is to check for any other common factors. And also remember that in that step 4, if there are more than 3 terms, you can also apply grouping. Okay, so those are some different methods that you'll want to apply. So I've got a few problems I'd like you to try. So in your spiral notebooks, we're going to take some notes on choosing a factor method. So I'd like you to pause this video and work together with your tables and see if you can break this down and factor it. After a few minutes, hit play and I'll show the solutions. Okay, well the solution would be, I first notice that there's a GCF of negative 2x in each of these terms. And that's going to leave me with y squared minus 8y minus 16. I lied, plus 16. There we go. Then I've got the GCF now, so now I look to see, is this a factor pattern? Well, since it's a trinomial, is it a perfect square trinomial? Well, I notice that the square root of y squared is y, the square root of 16 is 4, and if I double those and multiply them, I do get the middle term. So this can factor into this, and I bring my negative 2 down. So it's negative 2x times the quantity of y minus 4 squared. Okay, so hopefully you got that correct. In the next one, again, I'm going to notice that there's a GCF of 2y in both of these. And when you factor that out, excuse me, you get x squared minus y squared. So then within the parentheses, I notice that this is a difference of two squares. So I still have the 2y out front, but this is going to factor into x plus y times the quantity of x minus y. Okay. All right. The only other thing that I really want to point out to you is there will be some questions on whether something is factored completely. So if you have 3x squared times the quantity of 6x minus 4, is this factored completely? Well, one of the questions you want to ask yourself is there any more greatest common factors that you can pull out? Hopefully you recognize that in this term right here, I see a GCF of 2. Both 6x and 4 have a GCF of 2. So what we're going to do is we have our 3x squared times, we're going to pull out our GCF of 2, and we're left with this. So notice that when we pull that factor out, it just is going to get multiplied to this front coefficient. So it's going to become 6x squared times the quantity of 3x minus 2. Okay. All right, so I think this lesson is pretty much just going to let you kind of dive in and do lots of practice with factoring. I would suggest that you work together and you check answers and you stay on the right path so that you're not trying something, getting completely stuck, and not getting anywhere. One thing I do want to point out to you, if you look at, this is one of your book problems, 2z squared plus 11z plus 6. If you look at this, there is no GCF. So then we try to determine, is it a perfect square trinomial? Well, no, because 2z squared is not a perfect square. So then we go to this method, and we think, are there two numbers that multiply to get the product of 2 times 6 and add to get 11? So two numbers that multiply to get 12 and add to get 11. Well, 3 and 4 won't work. 6 and 2 won't work. 12 and 1 won't work. Negative 12, negative 1 won't work. So it is possible to have something that is unfactorable. It is possible to kind of hit a dead end and not be able to apply any of the strategies, find no greatest common factor, and we would just leave the answer unfactorable. Okay, so for the rest of the hour today, I'd like you to do homework section 8.6. Again, please check every once in a while a few problems in the answer key that will be up here and work together. Have a great weekend, and I will see you guys Monday.